Hello students, welcome to Inside Physics. We are going to learn self-inductance today. Electromagnetic induction is a good topic where the induced EMF will be found in any conductor or solenoid or whatever the shape of the conductor we take, and if there is any magnetic flux around the conductor and the magnetic flux is changing, then the induced EMF will be seen in the conductor where the magnetic flux is changing, varying with time. This is called electromagnetic induction. The electricity is induced. Electricity is flow of electrons. Current is nothing but flow. So the flow must be backed up by some electromotive force. That electromotive force is induced because of the varying magnetic field or flux. That is the concept of electromagnetic induction. Now here we see what is self-inductance. This is linked to a particular conductor or a solenoid or a toroid, whatever it may be. Now we see some theory regarding this self-inductance. So there will be a flux around the solenoid of n turns. There will be number of turns. If you take a solenoid of this shape, the number of turns, total number of turns is represented by n, capital N. And if there is any magnetic flux varying around this coil or solenoid, if there is a magnet which will be moving to and fro towards the coil to change the magnetic field around it. Unless we move the north pole or south pole of a magnet, we cannot have the varying magnetic field. So this field is, when it is moving towards the coil, will be inducing an EMF. That means the current will be in counterclockwise to oppose the movement of magnetic flux according to Lenz's law. Here we will see that the flux, variation of flux, the induced current have some relation. So what is that relation? So flux induced is directly, the flux, variation of flux is directly proportional to the current in the coil. So if we have number of turns as n, so we can write as is equal to n phi b. Here flux induction B is related to magnetic induction. So flux density, flux and flux density, this is called magnetic induction B or B bar, whatever it may be, because magnetic flux density is a vector quantity. Here we will see that B bar is a vector quantity, and this will be measured in Tesla, Weber per meter square. So here we will introduce a coefficient called coefficient of self-induction, which is represented by capital L, and here we write this as I. Here the coefficient represents what is the effect of, or what is the degree, amount of self-induction a loop or solenoid has. So self-induction means it is inducing the EMF by itself. It is having an EMF in the coil because of the varying magnetic field, and the magnetic field varying will be producing an EMF. Okay, so if we connect this to a varying potential, that means the coil is connected to a varying potential. The variation, this potential, this EMF induced because of this battery, and the variation of this EMF will be causing the magnetic variation in the magnetic field around this coil. Here see, the current flowing through the coil will be causing another magnetic field around the coil. According to, we know that every current carrying conductor will have a magnetic field around it, and we can represent the magnetic field around a current carrying conductor with the right hand thumb rule. So the curled fingers will be having the magnetic field direction around this conductor. In this way, if we connect the current to this solenoid, and this current is varying, the magnetic field generated because of the EMF and the field also varying, the variation of the field will induce another EMF, that is called self-inductance. The self-inductance must be represented by a letter called L, which is called coefficient of self-induction, or it is called self-inductance of a particular material. So here, what is the EMF induced according to Faraday's law? The EMF induced is equal to minus d phi by dt. This is variation of magnetic flux with time. So the variation of magnetic flux will induce EMF in a particular conductor. So here, if you observe this, and you can substitute as epsilon is equal to minus L d I by dt. I have taken this and substituted here, and if you can have n number of turns, you can have this like this by dt. Okay, the induced EMF. Now with this information, we can have the formula for the coefficient of induction, that is L. We can calculate the self inductance of a particular coil, so by having the terms which are related to magnetic flux. Okay, so here magnetic flux will be represented by, we know that a basic formula, B bar dot A bar. Okay, if it is a solenoid, we know that the number of turns in a particular coil and the flux multiplied by the number of turns, and here the magnetic induction due to a solenoid, we already know this is mu naught n I into A. So we can write like this as per this formula. Now if you multiply with total number of turns is equal to n into L, we can write in place of capital N, and mu naught n I A. Okay, here the magnetic field and the area of the loop, plane of the area of the loop and the magnetic field are perpendicular. So B bar dot A bar will be representing as BA cos theta, where here the cos 0, because the area of the loop, the direction of the area of the loop, this is the area of the loop, and the direction of the area of the loop will be like this, and the magnetic field will also be in this direction. So the theta between the direction of the plane of the coil and magnetic induction will be 0. Here we can take it as BA. So from that, B, magnetic induction due to a solenoid, mu naught, permeability of free space, N, number of turns per unit length, I, current in the coil, A, area of the loop. So here we can understand by this formula. I will write here N phi B is equal to N square or mu naught N square LIA. Okay, so if we already know from the formula, see N phi B, which I have written in the beginning, this is N phi B is equal to inductance into current. From this we can take the inductance as N phi B by I. This is already I have written in the beginning. So from this, L is equal to N phi B by I. So here what I can write, see N phi B is equal to mu naught N square LIA. So I will write L is equal to mu naught N square LAI by I. So I will be cancelled in the numerator and denominator. So here L is equal to mu naught N square AL. So this is the formula for self-inductance of a solenoid, and where mu naught permeability of free space and N number of turns per unit length, area of the loop and length of the coil. So here if we introduce any material which is having more permeability than free space or air, just like our soft iron, which is having a high relative permeability represented by mu r, then the self inductance will increase by mu r times, that means mu r mu naught N square AL. When this space inside the coil, this means previously there is no material such that it is having only air or free space, but when you introduce with a material like a ferromagnetic material which has more permeability, that means more susceptibility, then the self inductance will increase. So here this is the theory to calculate the self inductance. Now this induced self inductance, self induced EMF is also called back EMF. Back EMF means actually the back EMF induced because of the variation of magnetic flux, because of the variation of current in the solenoid, it actually opposes the decay or growth of current in the solenoid. The increase or decrease of the current in the solenoid is opposed by this EMF induced because of self induction, and this EMF, because it is opposing the increase or decrease of the current and indirectly opposing the variation of magnetic flux, this induced EMF is called back EMF. So back EMF is there to oppose the increase or decrease of current. So because of this opposing force, we need to do some work to maintain the current in the coil. If there is anything opposing against something, if we want to maintain that thing, we need to do some work. In the same way, if we want to maintain the current in the solenoid which is getting opposed by the induced back EMF, we need to do some work. So how to calculate the work, and how the rate of work, the power dissipated, electrical power, that is calculated with the mathematical relation dW by dt. Rate of work done is nothing but, so this epsilon is induced EMF. So the modulus represents only the value but not the direction. It is opposing, we know, and here we already know this epsilon is nothing but minus L di by dt. We already know this. So here I will write the rate of work done, nothing but power. The rate of work done is nothing but power. Here minus L I di by dt. So dt will be cancelled, and here if you want to get the total work done in maintaining the current in the solenoid, we can integrate this one and get the total work done to maintain the current when it is at 0. To get it to current I, to maintain the current at a particular level, we need to integrate and find out the limits as 0 to I. Here minus L is a constant for a material, coefficient of self induction constant. 0 to I, this is nothing but I di. Okay. So this minus we are not considering because we are only considering the value of the EMF. So no representation for the direction, as the work done is a scalar. Okay. Here if you observe this, the representation will be coming out as this is I di, and this comes out to be L I square, okay, by 2 between the limits 0 to I. So I will write it here again. Work done, total work done in maintaining the current in the solenoid has come out to be 1 by 2 Li square. This just looks like the kinetic energy formula, which is half mv square. It represents the formula half mv square. Look at this. So we can understand by this the self inductance, the L, is nothing analogous to mass in the mechanical study. So when you are studying the mechanics, that means the motion of objects, the mass is considered as the cause of inertia, right? The inertia is very a reluctant force which will be opposing the movement of any mass. Already moving mass, if it is already moving, it is cannot stop it because of the inertia. So here L is quite analogous, similar. Analogous means similar to mass. So this we can consider as this mass is opposing this L, self inductance is opposing the current, growth of current or decay of current in the solenoid. So this is can be considered as electrical inertia. Electrical inertia. Just like our inertia due to mass in our mechanics is opposing the force, inertia of rest, inertia of motion, inertia of direction. We have three types of inertia. Just as the mass is the causing inertia to oppose the motion of objects, here the L is causing the current, opposing the current to grow or increase or decrease. So this can be considered as electrical inertia. Okay, so this is the concept with a single solenoid, and if you have two solenoids which are mutually inducing an EMF in each other, then how to approach that situation. And in the first coil, if we have two coils, there is always a first coil and a second coil. So we can write that uh, the flux induced because of the current in the second coil. So it is a first coil, and I will write the same type of coil besides this coil. This can be noted as first coil and this is second coil. From the theory, if the flux induced due to the current in the second coil, the current in the first coil is I1 and the current in the second coil is I2. Take it as I1 and I2. So because of I2, there will be a flux induced in the first coil. That is what mutual induction. The electromagnetic induction always says there will be a mutual thing here. The flux will be induced because of the current, and the variation of magnetic flux will induce the current in the coil. It is a mutual induction, and here we can write the flux induced in the first coil due to the current in the second coil can be written as M11 I1 plus M12 I2. So already this is the current flowing in the first coil, I2 current in the flowing second coil. Mutual induction because in one due to 2, 1 2 means this induction happened because of the second coil in first coil. 1 2 induced EMF in 1 due to 2, or variation of magnetic flux in 1 due to second coil. Here now the EMF induced in the first coil due to second coil. So there is a very magnetic flux here, and because of this magnetic flux there is an induced EMF in the first coil. How we write this? We can write this as minus M11 di1 by dt minus M12 di2 by dt. We already know this induced EMF by considering Faraday's law. If you observe this M11 induced EMF because of the first coil only, induced in 1 due to 1, that is what 1 1 is. So this can be definitely considered as L, self inductance. So coefficient of self inductance can be written as M11. Okay, so this is how we calculate the coefficient of self inductance, or it is called self induction. So this equation now can be written as minus L1 di1. This is the self inductance of first coil. That is why it is written as L1. Okay, so this is how we understand the theory of self inductance. So we will see what is mutual inductance in the next video. Thank you.